Startups get the party, startups get the party started. Startups get the party, startups get the party started. You want tech and tacos, tacos and tech, you know we got it, eh? Startups get the party, startups get the party started. Startups get the party, startups get the party started. Startups get the party, startups get the party started. You want tech and tacos, tacos and tech, you know we got it, eh?
And welcome back to the Tacos and Tech podcast. I'm your host, Neal Bloom. I'm thrilled to have on Troy Helming, founder and CEO of EarthGrid. Hey, Troy, welcome to the pod.
Thanks, Neil. So happy to be back on talking with you.
I know it's good to have you here. It's been a bit since I've seen you in person, so hopefully I'll come out and see some boring soon, which would be awesome. But do you want to give us a quick high-level overview of what EarthGrid is, and then we're going to take it all the way back?
Yeah, sure. So EarthGrid has patented technology that I invented about 8 years ago that is essentially plasma excavation and tunnel boring using effectively like Star Wars lightsabers to vaporize rock and soil with a Mandalorian jetpack blowing all the bits of rock out the back of the tunnel or out of the trench.
Love it. Very visceral. And it's working, which is awesome.
It
I
is.
have some melted rock on my desk from when I came out and saw it maybe 2 years ago, I think.
It sounds about
Um,
right.
yeah, it has come a long way, which we're going to talk about. But why this? I got to know, like, where did it all start from you in terms of going underground?
So the origin story goes all the way back to 2016. At the time, I was running my seventh company, Pristine Sun. It was the leading developer of community solar farms in California and about a dozen other states. Anyway, we had a project in Northern California. We had to downsize by 75%, lost out on, three-fourths of the potential revenue and value of the project because the transmission line that we were connecting to didn't have enough capacity. We looked at another line and it was about 3 kilometers away under protected creeks and wetlands. And we're like, okay, let's get a permit to do an overhead line. And that was going to take almost 18 months minimum, probably 2 or 3 years. So we would have lost our contract. And we got quotes for going underneath the 3 kilometers. And the cost was so insane. It was like a third of the cost of the solar farm. So kill that idea. Anyway, so we're disappointed. We're drowning our tears over beers, San Francisco bar. And one of my solar engineers, Dominic, is bragging to his girlfriend about how when he was a Navy SEAL, he used to go underwater and cut through the side of enemy ships with a plasma cutting torch to take over the ship. Plate falls in, water rushes in, pow, pow, pow. We're like, dude, you're such a badass. But that night, I woke up in the middle of the night. I was like, huh, he said it was 20,000 degrees, could take his arm off if he wasn't careful. That's hot. That could probably go through rock. Up all night researching, couldn't stop thinking about the idea. Eventually built a little prototype as a secret side project with my own capital, funded everything for the first few years. Fast forward to today, we now have our first machine that's fully commercialized. It's digging ditches and trenches and ground vaults and caves and bunkers. That's the excavator and the tunnel boring machine. I'm sure we'll talk about that.
Wow. So it all came because of some Navy SEAL technology, which probably has been around a long time, right? It wasn't revolutionary to the Navy SEALs either,
That's right.
anytime recent. But I think even further back, you went through like the 90s fiber broadband wars, which
Correct.
also was underground, right? And as
Correct.
well as in many other energy worlds as well too. Just set the stage a little bit for just like what's been the ground war, if you will, for trenching and tunneling.
Well, I've always been fascinated and passionate about clean energy, renewable energy. And that's because when I was a kid, growing up, one of my chores as a little boy was to maintain our solar hot water heating system that
Hmm.
my dad put on our house. He built his dream home. He's a successful entrepreneur as well. And it heated our pool, our hot tub, our water in the house. And in the wintertime, we shut the pool down and it heated the air in the house. So it was a really cool system. I was around it since I was a kid, right? And I heard about my parents talking about our dependence on foreign oil and the oil shocks and all that. And so and my mom came down with cancer, and we lived near coal plants, which have all this mercury and toxic pollution. I thought that might have played a role. So anyway, I always wanted to get in clean energy, but when I got out of college, business school, there were no jobs in clean energy. So I went to work for AT&T, did telecommunications for a while, did projects, hardware type projects for businesses and so forth. And then I started the first wind farm company in Kansas, and that became the largest wind developer in the entire United States in 2017 and number three in 2018. It's now a $35 billion division of Enel Green Power, the huge Italian utility. But in building wind farms, and then when I sold that company, I switched to solar. We encountered so many challenges with interconnection. The biggest impediment to the growth of clean renewable energy, which is by far the cheapest form of energy, the biggest blocker or impediment is lack of transmission lines.
Hmm.
So I'll pose a question here to you and your listeners. If you had to guess, how long do you think it would take to permit and build a new overhead transmission line in the United States or in Europe? The answer is the same in both places.
I mean, it's got to be years. Just don't know how many. Or is it a decade? I don't even know.
Yeah, the typical range is 10 to 20 years, and the average is about 15 to 16 years. And most projects never get built because community opposition. Oh, it's going to cause cancer for my kids. It's going to lower my property values. It's ugly, blah, blah, blah. So they really struggle to get those things built. And if we could go underground, put them underneath public roads, we could do it in a year or two, all the permitting and the construction, regardless of the tech, whether it's ours or somebody else's. So anyway, that was a big kind of I don't know, a cloud hanging over the wind and the solar industry for decades. And when I came up with this idea, I was like, whoa, this could solve that. We could rapidly accelerate the clean power revolution because we're electrifying everything. Cars, heating in our homes, our stoves, industrial processes, everything is moving to electric because it's a more consistent, reliable form of energy. It's not as volatile as fossil fuels.
Amazing. I mean, one, to talk about clean energy sounds like it was way, way before it had all the names that we have called it today. That's for sure. In general, people just need reliable and sustainable energy. That's it, right? That
Yes.
doesn't harm us and actually empowers us to do more. Was that evident even back from 90s and early 2000s that regardless of the technology, solar versus something else, it was just that we were lacking energy and we needed access to 10 or 100x more? Is that what was powering you?
Yeah, that, but also just the notion that coal was so dirty and expensive. And I saw that I did a lot of research when I got into the industry. I saw that it's a technology industry and technology costs lower every year, right? Whether it's wind or solar, the cost of those forms of energy generation keep lowering every year. And the faster the industry goes, the faster the costs drop. And that compared to an extraction industry, whether you're extracting oil, gas, or coal, or uranium, or whatever, those costs, they fluctuate, but generally they're on an upward trend in terms of cost of extraction because we've gotten the easiest sites, already developed. So I knew that eventually those lines would cross.
Mm.
And I even wrote a book back in 2004. Please, nobody read it because it'll put you right to sleep. The Clean Power Revolution. But I wrote about this, and I built my dad's an economist, so I built the economic case, and I was like, okay, probably sometime in 2015 or 2020, those lines are going to cross. It actually happened in about 2008 for wind and about 2012 or 13 for solar, meaning and it's now cheaper to build a new solar farm or a wind farm than to leave an existing gas plant or coal plant operating. It's actually
Mm.
cheaper to shut those plants down and build new solar or wind. That's how much the cost has dropped.
Wow. Interesting. But energy companies, I mean, the big thing for them is maintenance and machinery, I'm guessing, in some of the pieces of why they don't, actually go and maybe chop off a limb, which is kind of what it feels like. Is it just risky?
Yeah, I mean, there's sunk cost in these multi-billion dollar, $100 million plus, power plants, and so it's a difficult proposition to tell your investors and your lender, hey, we're going to shut this thing down and write it off as a loss because we're upside down, we're losing money on this plant because solar and wind are kicking our butt. Here's another little trivia question. in the last 5 years, what percentage of all new power plants in this country were solar, wind, and or batteries?
Ooh, it's a good one. Over 50%, 60% maybe?
Yeah, it's well over that. It's about 95% of all new power plants in the last 5 years were solar, wind, or batteries. Very little coal, actually no coal. We've been shutting coal plants down every year. And a little bit of nuclear, mostly natural gas has come online in the last 5 years. But
Wow.
in terms of that little 5% sliver.
All right, we're making progress, that's for sure.
Yeah.
But one big area that's missing, obviously, is the construction aspect of it. And actually, once you have a plant, you got to get whatever it is to the people, right? And energy is just one. There's so many other infrastructure pieces that need other things now. Now, and we'll get to data centers because, we'll get there because we have to. But how is it all when even when you wrote the book and even as you saw this coming around, the trenching, tunneling piece, how is that all mathing in? Because it's hard to math policy and regulation into all these pieces, right? How do you start figuring out those kinds of costs to, bring power to people?
Yeah, well, it's not just cost, but it's also permitting time, right?
Right.
The need for power, as you already pointed out, is so acute for data centers. The explosion of AI is just part of it. Data center energy growth was growing really rapidly even before AI became so popular and so such an integral part of our economy. Anyway, and so permitting for overhead, as we already discussed, takes so long. The two things that can slow the clean power revolution to get more cheap renewable power are permitting, which we talked about, and interconnection, which we talked about, which means lack of transmission lines. And so, as I talked about, it's kind of a perfect storm. When I came up with this idea, I was like, okay, well, we can go underground, and it's about the same cost to go underground as overhead now. It used to be like 7 to 20 times more expensive to put power lines underground. But with our tech, we use air, which is free, and electricity, which is cheap, thanks to solar and wind. And so our cost to put it in is so low, it's up to 90% lower than conventional undergrounding. So I'm like, all right, we got the cost pretty well solved because it's apples to apples on overhead. Permitting is way faster because nobody really cares if the lines are underground. And then on that note, EarthGrid over the last 5 years spent quite a bit of time and money becoming a regulated utility. We're a telecommunications utility in 46 states and counting. So as a utility, we basically get near guaranteed access to put our tunnels under any public road, whether it's state, county, or city roads. So that makes permitting super fast because we get that the utility benefit, and we're a public benefit corporation, and that helps us with those utility status acquisitions. And then third is interconnection. So we're talking to a number of solar and wind developers and data center companies, and we're saying, hey, we can be your underground extension cord. We can connect a solar farm over here that's been waiting 7 years for somebody to build a transmission line so they can build their project. I hear this all the time, but it's only 20 kilometers, 15 or 13 miles away from a data center site or a substation that has capacity near a data center site. And so we're looking at a lot of those kind of opportunities where we can solve that problem. And then, to your point, it's not just power, it's also water and fiber, and they need fire suppression. And sometimes they need natural gas as a backup or as a supplement to solar or wind. So anyway, we're super excited that we're kind of in the right place at the right time.
Okay, let's take it back a little bit to just like the development, the technology development, but more because there's a lot to peel back here. I think you also underplayed the being a registered utility, which we'll get to as well, because that helps a lot in terms of
It
time
does.
and cost on a
Yeah.
lot of things. But back in 2016, what was the state of plasma? Was plasma even looked at as used in construction or anything, or was it really like a very niche area, like where were you seeing it?
Yeah, it was used primarily in two areas for cutting metal. Plasma cutters were and are a very common thing to cut through metal because plasma is the fourth state of matter, right? It's solid, liquid, gas, and then plasma, and it's very hot. Our temperatures are 27,000 degrees Celsius at the core of our lightsabers, if you will, plasma torches. Anyway, Plasma cutters and then furnaces. So plasma has been used since the 1970s in like steel arc furnaces, solid municipal waste, where they, basically take trash and turn it into dust and slag and ash, that kind of a thing. There were other use cases like remediating contaminated soil using plasma furnaces and things like that. But those were the two primary use cases. Nobody was using it in construction. It just was this idea that again was inspired by this Navy SEAL. And so I did look up though, there was an old paper from Los Alamos National Laboratory in the 1970s where they put plasma on rock and it worked, but there were issues like they didn't have very good power control electronics back then. Price of electricity was expensive relative to the economy back then, blah, blah, blah. Anyway, so hopefully that answers your question.
Yeah. And so what were the first things you did technically? Like what were the technical milestones you had to get to actually start, melting rock?
Yeah, well, after I did a feasibility study with a big plasma engineering firm and filed a number of patents, we built the first prototype. And like I said, it was a secret side project in a warehouse in Oakland with a leaky roof and dirt floors. And anyway, it was a pretty sketchy place. But we punched a hole through a boulder with a rudimentary robot that just basically slid the torch forward through a boulder like not quite a car-sized boulder, but like half the size of a car. And it worked. And we're like, holy cow, that was fast. It went right through it. Because I was like, this is either going to be a billion-dollar company or a nothing company.
Mhm.
And that was the moment of truth.
Amazing. What time period was that?
That was, let's see, early 2018. We finished the prototype in late 17 and started testing in early 18. And that's what, after we punched the hole through the boulder, that's just the first technical challenge. Then we realized, oh gosh, how do we get all the spoils, including lava, out of the tunnel?
Yep.
And so we spent a number of years perfecting all the various subsystems, including our code name for the spoils removal system is Thunderdome. And we came up with a system, took 7 iterations to finally get it right, but we came up with a system that is solid state, meaning no moving parts.
Oh, wow. You want to share more about that?
Sure. Yeah, it's we filed some patents on it too, so we can talk about it now. But it basically we just fluidize the spoils. Plasma at that temperature causes either spallation, which means the rock just kind of flakes off in little bits or flakes, like cornflake sized bits. Probably don't want to eat it. Or dust or sand, and so or lava. Those are kind of the four primary spoils that we have. And so we fluidize that with basically a vortex, a violent tornado inside the tunnel with movement of air. And then we use powerful mining vacuums to extract all that material. So it turns the lava, and there's usually no more than 20% lava, even in high silica rock like sandstone, but it turns the lava into silica sand and everything else into sand and dust. And because we don't use water or chemicals or lubricants or drilling mud, bentonite, or any of that, it's all dry and we can sell it. It's
Mm.
useful for concrete or asphalt manufacturing.
Wow. Is there a part that's also ends up being structural because you're heating things? Is there anything hard enough that actually ends up being like wall structure pieces from this?
If yeah, because we're non-contact, we don't ever touch the rock. We're using it's energetic boring and drilling. We're not causing fractures all over the rock. We're not grinding away at it, and so we're not weakening the rock like conventional tech, and we're not paying to get rid of the muck, the toxic muck that could burn your leg off if you stand
Mm.
in it. But the structural, if it's hard rock, there's hard rock like granite tunnels all over the world that have no lining at all. There's no concrete or structural in there at all because it's strong. There's caves all over the world, that go through earthquakes and anyway. But our Atlas patent, anyway, it's automated tunnel lining and application system. So we spray with shotcrete concrete as needed to line the tunnel. But to answer your question, if there's silica in the rock, or if there's sand in there, it will create a glassy lining or it will anneal it and create some level of ground support and structural support before we come in and strengthen it if we need to strengthen it.
Mm. Wow. So I remember when and I think we first met in 2022, which is I think when Capital
Right.
first participated in a round of funding then.
Yep.
At that time, the idea was both tunneling and trenching, uh, which trenching has its own, I'm guessing, different needs because now you can't go underneath as much stuff and you don't have your open air, so you lose some of the heat. Like, what's the difference? Take us through a little bit between the difference of those two, and if that's still strategies that you're going through.
It is, yeah, for sure. There's a need still for trenching and excavation. And you're right, we lose up to 80% of the heat to the air because it's not in a confined space. So we're working on designing what we're calling dragon wings that will fold over the trench as we're torching on it. And we have videos on our YouTube channel that people can check it out if they want to see it. But yeah, there are needs for trenching. Like we're talking to some of the most of the big tech companies, hyperscalers, and on a site at a data center, they have multiple trenches, and sometimes it's a trench underneath a trench underneath a trench, because you've got, water and sewer, and you've got fire suppression and power and data, and there's, rules, and code and how far away these lines have to be from one another, and they crisscross and they're all over the place. So we have that. We have one of the world's largest tech companies asked us to bid on carving out a huge hole in the ground for a water cooling pond
Hmm.
in granite next to a data center. We have utilities that are asking us to carve out the side of mountains so they can pour another concrete pad to expand a substation. They can't use dynamite next to a substation because it will cause vibration, and transformers can be damaged if there's any vibration. In fact, we did a test for the Norwegian grid operator Statnett in Trondheim, Norway, and they put like 30 sensors all over the ground and the rock wall and everything to see if there was going to be any vibration with our process.
Hmm.
And they detected none. So they're like, okay, so we were just told that we're going to be getting our first project in Norway to do what I just said, carve out the side of a mountain with the excavator.
Wow. So a lot of use cases. A lot of use cases as in a variety of ways. I mean, you're a technology, but you're also full like prime contractor, if you will, for doing some of these projects. And then being a registered utility, you own your own projects too, right? Theoretically, you could
Correct.
go build your own tunnels. How do you how do you look at this kind of as company strategy? Like what is the big vision versus what's today and all those pieces?
Yeah, well, for those who are curious, if you happen to go to our website, you'll see our product names because we have a sense of humor, so I'll just share them. But Badass and Boom are our products. We're not going to sell these machines. Instead, Badass stands for boring and drilling as a simple service, or boring and digging as a simple service. So that's our construction model that we just talked about. So we'll either be the prime or a subcontractor to a big prime or whatever. We come in, we solve hard rock problems. We have no geology risk at all. We can get through anything, including the hardest rock like basalt and granite and quartzite and gray whack and everything. We've done over 1,000 tests. So we can go through anything, even steel. So we'll do that on a construction type basis, and margins are going to be good, like 60% or better. We've been told by one of the biggest construction companies in North America that they turn down over $2 to $3 billion a year of trenching jobs because they don't have a good solution that is, quiet and non-contact and can get through the really hard stuff. So that's a business model for both the trenching and the tunneling. Boom stands for build, own, operate, and maintain. So as a utility, yeah, we'll own the tunnel because as a utility, AT&T, Verizon, Crown Castle, they own their own conduits underneath the roads as well, right? Or above or whatever. So we'll own our own tunnel, and either we'll lease out space for decades and collect lease payments by being an underground real estate developer and leasing out space for water, power, fiber, gas, freight, tubes, hydrogen, whatever. Or we'll put our own lines in and we'll charge a toll on all of the commodities flowing through our tunnels.
Mhm.
And that
And
generates revenue for decades, which is why we want to take the company public in a few years. And we have Bank of America and a few others we've been talking to about taking us public.
amazing, huge, and huge opportunity, obviously. And it's in it, the technology is now showing that it's doing it. What's next? What do you need to knock down next to start laying the ground for some of these pieces?
Yeah, the only thing that's missing is capital. It's not just hardware, which you and your listeners know, deep tech is hardware, but industrial technology or industrial machinery is very capital intensive. So we're raising our Series A right now. We have two lead investors, and it's going well. We've always oversubscribed our rounds. We're going to offer it on crowdfunding, so you can find us on WeFunder. For us, it's one entry on the cap table, but it allows basically anybody, retail investors, to take part in this creation of what we believe is going to be massive wealth as we go out and build an underground network of tunnels, effectively an underground super grid, power, fiber, and water and freight moving around North America, and eventually we'll connect continents around the world.
Hmm.
So anyway, capital is number one, but number two is we built our first field-ready tunnel boring robot. The excavator that was ready in the fall of last year, and that's why it's bidding on projects in Norway and the US, and we're going to start making money finally, which is very exciting. Revenue, customer contracts are being signed. Um, but the tunnel boring robot is a harder problem. But we got the Thunderdome, the spoils removal system integrated into it. We built it, and we have videos on our YouTube site and so forth. But we just completed our first tunnel, the world's first plasma bored tunnel. It's just under 10 feet into the mountain, about 3 meters into a granite mountain, and it's 1 meter diameter, a little more than 3 feet in diameter. And we did that in about 2.5 hours. And so that's fast. That's way faster than diamond carbide bits, going through granite. But we weren't optimized for speed. So we're gonna break that thing apart. We're doing a show and tell, two of them over the next month or two for people who are interested as either customers or investors at our testing facility near Yosemite National Park in California. So people can reach out to us, info@earthgrid.io, if you want to go see the tunnel, see the machine. But anyway, got to perfect that machine. So we'll break it apart, rebuild it. We learned a lot and perfect that, and we think that'll take a few more months.
Okay. Yeah, and there's some great videos from the engineering team of kind of vlog style of getting it to there, which is awesome. I love that you guys are building in public like that. You take us through a little bit of this AI moment because I think most people are seeing the demand just skyrocket everything. Is it feel the same for you compared to the energy demand and now suddenly with
Yeah.
what's going on there?
For sure. Yeah. I mean, we're getting inquiries from a lot of different locations and sources to solve the infrastructure problem. Like we've heard that some of the big tech companies own property for data centers that's still dark because they can't get either power or water to the site. Fiber is easier. And so we can potentially solve that problem. Again, be the connection between a source of water or sort of the source of power to the site or someplace near the site where they can access it. So yeah, it's a great a great time to be in the underground infrastructure business. And the need it's unbelievable. Even if you subscribe to the notion that AI is a bubble, as I said earlier, the need for compute power just at data centers, even without AI, is growing very, very rapidly. And even if AI is a bubble, it's not going to stop. Maybe it slows down a little, and maybe it doesn't. Maybe it accelerates. But the need for power is crazy, and we can solve it with solar and wind if we just have enough transmission lines.
Speak to a little bit of how you're powering your tools themselves. So we actually didn't touch on that part. How do you power a plasma system?
Yeah, there's a misconception out there. In fact, even some incorrect articles that have been written that we require a huge amount of power, and it's a lot, but it's not that much. We need for the excavator about 1 to 1.5 megawatts, and for the tunneler for a 1 meter diameter, we need about 1.5 to 2 megawatts. So we actually own our own generators. We have, I think, 2.5 megawatts of generating capacity. So worst case scenario, we can burn natural gas, gasoline, or diesel to run the plasma torches. But most construction projects are permitted over some period of months. You know, before you show up at the site, you know how much power you need and this and that. So I'll give you an example. For subway tunnels, or any type of tunnel using conventional tunnel boring machines, like Elon's company or anybody else using more conventional technology, they need power too. They need sometimes 10 to 20 megawatts or even more if it's a big machine. And so they simply, again, permitting takes months, sometimes years for these construction projects. And so they simply say, okay, local utility, we need temporary power on the site, and here's how much we need. So that's our first choice, is to just use grid power. And because our biggest expense is electricity, right? Running the machine. But because electricity, as I said earlier, is cheap on a wholesale basis because of solar and wind, we're still, if we get access to grid power, we're still far, far cheaper than any other alternative for trenching or excavating, with one exception. Dynamite, we're about the same price if we're using grid power, and we're more expensive if we're using diesel power. But dynamite's not allowed to remove rock in a lot of areas if you're near any homes or structures. And that's where we can come in. So anyway, yeah, either use a generator or use grid power. And the last thing I'll say is a lot of our projects we're talking to customers about, there's a solar or a wind developer involved that wants to build a new solar farm or a new wind farm. And they're telling us, look, we'll give you power for free if you can help us solve this problem and,
Mm.
get us connected to our customer.
Amazing. Well, look, you've been in the business a long time. Energy, especially clean energy, has this two steps forward, one step back often because
Yes.
of so many things, politics, new sexy hot things. How do you tell me about a moment where you're like, oh no, like we've missed our moment or the tech's not going to get there fast enough. Have you ever had those in so far in EarthGrid?
Oh, in EarthGrid, no, we haven't, because we're energy agnostic or infrastructure
Mhm.
agnostic. I think infrastructure is purple, blue and red states, blue and red counties, blue and red people can all agree that we need better water, power, fiber, broadband, all of that. So we haven't really been affected by that, but I have had some very unpleasant periods of my life in what I call the solar coaster, with the solar industry going, up and down and having setbacks, whether it's, a politician in Washington, D.C., that's anti-renewable, or whether it's a dispute in Congress where a tax incentive is not renewed. All forms of energy generation, except for renewables, have permanent tax credits. But renewable energy has never been made permanent. And so when it lapses, the whole industry shuts down until Congress pulls their head out of the sand and renews it again so that we can compete on a level playing field with coal, gas, and nuclear and everything else. So there's definitely been moments, whether it's tariffs or Congress or political issues, there have been challenges. But as we said earlier, even despite that, the last 5 years, 85% of all power plants are solar, wind, and batteries. Why? Economics.
Mhm.
Cost curve is just so attractive that despite all of the noise and nonsense, the industry still continues to find a way to grow.
Mm. Well, and like you said, regulation stops lots of people. You have found a way to use it as a weapon, right? By action, right?
Interesting. I have not thought about it that way, but you're right. That's
I
good,
mean,
Neil.
that's a judo superpower right there
Uh,
to
uh,
actually be like, well, we are a utility and we are going to ride the wave of regulation to a certain regard, right?
I love
Um,
it. I'm going to give you credit for that the first time.
okay. You can have it for sure. 10 years from now, do you think you're more proud of what's changed from how much infrastructure you've built and how much things are flowing, or from what is actually just changed from our quality of life because of what's flowing underground?
Yeah, that's That's a tough one. I would say the latter, quality of life, because in 10 years, I believe EarthGrid will own a supergrid, an underground supergrid, and we will be providing better broadband, cheaper, cleaner power. Our food, our air, our water will all be cleaner because there'll be less toxic pollution from gas and coal plants. So yeah, it'll be quality of life that I'll be more proud of.
Amazing. Well, 10 years is a long ways away. We know that for sure, but you've been
Yeah.
working in many 10-year frames for a while, and this 10 years feels like the next 10 years is your moment here for the robot to break through. That's for sure. Break through a few thousand miles, and then, like you said, through other continents. One thing that probably has already have a great quality of life is the things that we eat, and therefore probably won't change too much. Maybe how food is grown, I don't know, but the food itself, luckily, we love food, and being the Tacos and Tech podcast, everyone's got to know what is the food that you go to? What are the tacos that you grab for at the end of a day when you're shaking off all the dust from a grinding site or a boring site, sorry.
Yeah, my go-to spot is El Toucan, like the toucan bird. It's in Richmond, California, which is where I live. I live in Point Richmond by the yacht club on the water. And anyway, so yeah, tacos El Toucan is my favorite. They have red burritos, red tacos, and just yeah, it's amazing. And they're open super late. Sometimes I'm up late working or working out or training Ninja Warrior obstacles or whatever, and so it's my go-to.
Love it. All right. Well, I have to come visit. I still haven't been to Richmond to see you, so that will happen. And then maybe on a trip out to Yosemite to see the job site in the next few months, we will stop and have some El Tucan tacos and burritos. Would love to do that.
Sounds great.
Troy, thank you so much. Thanks for being on the pod, and thanks for building the underground super grid.
And thanks for having me, Neil, and I appreciate your time and attention.
Of course.
Tacos and tech is on smash for the green guacamole. Keep accountants counting beans. Contador cuentan frijoles. Founders trying to raise some queso. La vida San Diego. School of rappy, rapping fire. Tortillas round jalapenos. In these modern times of craft beer and coffee, my coding yoga posse. Fold the body, origami. We be surfing Coronado. Eating tacos el gordo. The tacos stand in puesto. Lucha libre and sombrero. Gotta shout out Tecos, Tecos by the ocean. Watch the sunset. La Jolla shores. Entrepreneurs trying to get funded. When San Diego Startup Week is popping in the summer. Oceanside to Tijuana. SD be full of hustlers. From couch surfing to penthouses right on the beach. Tech leaders who believe stars are within reach. We interviewing founders who be shooting for the moon. Hashtag SD Tecos with your host, Neal Bloom. Come on! Startups get the party. Startups get the party started. Startups get the party. Startups get the party started. Startups get the party. Startups get the party started. You want tech and tacos, tacos and tech. You know we got it. Hey. Startups get the party. Startups get the party started. Startups get the party. Startups get the party started. Startups get the